Hello and welcome to Sprott Radio. I'm your host, Ed Coyne, Senior Managing Partner at Sprott Asset Management. I'm pleased today to welcome a new guest to Sprott Radio, Gary Coates, Manager of Market Development and Technical Education at the Nickel Institute. Gary, thank you for joining Sprott Radio.
Well, thank you for having me.
Before we dive into the world of nickel, please tell us a bit about yourself and the extensive work you and the team do at the Nickel Institute.
Sure. Well, first of all, I'm a metallurgical engineer. Got my Bachelor of Engineering degree at McMaster University in Hamilton, Ontario. I worked nearly 25 years in the stainless steel business with a leading stainless steel producer in Sweden. I even lived in Sweden for 5.5 years and really got my real education there, shall we say. And then for the last 25 years, I've been working at the Nickel Institute. Right now, we have 4 different divisions of it. It's a very diverse organization. We're global all around the world. We have a group that I work with is the Market Development Group, and we have a group called the Science Group, which is really the Human and Environmental Science Group. A lot of them are toxicologists. And then we have a group called Sustainability and Public Policy. They're the ones that deal with regulators. And finally, the Communications Group, the people who write the magazine, get out the podcasts that we do ourselves, the blogs, etc.
Well, it must be fun to be hip now, right? Nickel is talked about pretty much in every corner of the investment universe as we talk about battery technology. And let's stay on that for a moment and talk about how nickel is really evolving. Me growing up, I thought about nickel as just simply a nickel. And I was surprised to learn how much copper is actually in an actual physical nickel, which we don't really use much anymore anyway. So, talk about how nickel's evolving and how relevant it is today, because it's top of mind in the modern world as we talk about battery technology. So spend some time talking about that, if you would.
Sure. It was a very expensive metal back at the beginning of the 1900s, but it was one of the usage was coins, as you mentioned, and certainly in Canada, the nickel was pure nickel. And even today, a lot of the coins are nickel-plated steel in Canada. Now, as you say, we're not using coins so much anymore, but that was one of the more important areas that people saw or came in contact with it. But we call nickel the hidden metal because it is in a lot of things that you don't obviously think of. And I mean, stainless steel, 2/3 of all nickel goes into stainless steel still to this day, and you don't think of it. You think of, well, it's chromium that makes stainless steel stainless, but nickel gives the stainless steel properties. That means you can form it easily, weld it. So your kitchen sink, for example, when you're deep drawing that from a piece of metal, the nickel gives it the property where you can deep draw it. Some of the more recent development work has been with batteries, as you mentioned, and certainly batteries are an up and growing market for nickel. Most people remember the nickel-cadmium batteries, and that was one of the first ones. Of course, cadmium is a very bad metal to have, so that got almost completely banned around the world as a battery. There are still some around, actually, but it's the different chemistries of nickel batteries that are used for primarily electric vehicles today. Not the only chemistry available, but Elon Musk at Tesla. I mean, he was the big promoter. And even though we called them lithium-ion batteries, he called them nickel batteries because there was more nickel than lithium in them. And the goal today is to have batteries with an even higher percentage of nickel in them. Just recently, people have talked about a lithium-ion battery where there's 90% nickel in it. The idea being that nickel contributes a lot of good properties to the driving range, the energy storage property of it. And so there is interest in it. But as I say, there are alternatives, and especially in China, where maybe most people don't drive quite as far as we do here in North America, and they use a nickel-free battery there, even in the Teslas that they have, the smaller Teslas, because they only will drive maybe 10, 20, 30 kilometers, on an average trip.
Well, that's interesting. You bring that up about it as far as the higher storage and longer range. That's really one of the primary needs then for nickel is it allows that battery to be more efficient and store that energy longer. Is that fair to say?
That is fair to say, and certainly in North America we are used to driving long distances, so that's very important. You need energy for either heating in wintertime or air conditioning in summertime in most parts of the world, and that of course drains the battery too, and that's why the nickel chemistry batteries are used as the number one source of EVs batteries in North America. And even Europe.
And what about then the availability or accessibility? Is nickel fairly easy to access for batteries?
It's interesting. Nickel is being used more and more all through its history. Maybe 5-6% every year increases. And that's because there's increasing demand for nickel in stainless steel, for nickel alloys, and now for batteries. And batteries contribute roughly today 17% of the nickel produced in the world goes into batteries, where maybe 5-6 years ago it was 3 or 4%. The processing of nickel from the ore to the final product where it's needed in batteries is fairly complicated and fairly expensive. So plants that are doing that are in the several $billion range to actually get commercial production. There is enough nickel ore to go around. We just have to ensure also that it's refined in an environmentally acceptable way. Most people think of Sudbury. That's where they practiced the moon rover vehicle because it resembled the moon's surface. In the old days, of course, you did allow all the emissions from the operations to just go out. And now, of course, there's extremely significant environmental controls where we don't do that, at least in North America and Europe. And Asia is coming along that way. They were a little bit like North America 70, 80 years ago, but they're coming along that way. They still have a long way to go in many ways.
Well, let's stay on the refinement side. So often when we talk about metals in general, there's gold and gold mining companies, right? And they're predominantly a gold mining company. Is that true in the nickel, or is nickel a byproduct of other mining? Talk a bit about the mining industry as it relates to nickel.
Sure. There are two main types of ores. The sulfidic ores, the ones that have sulfur in it, were the easiest ones to convert to nickel. They're also the ones that resulted in a lot of the killing the environments around because it released sulfur dioxide, which created sulfuric acid in the atmosphere, and then killed trees and fish and whatever. Of course, that's all been changed now. Those ores were primarily nickel ores. Yes, there was a lot of byproducts with them, copper being one of them, but also precious metals like gold, platinum, palladium came along, and some years the nickel industry made no money on the nickel. They made the money on the gold and platinum and stuff like that because there was always a high demand for those materials. The other types of ores are laterite ores, which are oxidic ores, and they're a little harder to refine. They can be done, and one of our companies, Sherritt, has been working with those for many years now. But the Chinese have come along in more recent years and produced a lower grade nickel product that can be used in the lower grade stainless steels. And that has helped to supply nickel for stainless steel. You can now, with technology that's been recently developed, create what we call Class 1 nickel, a relatively pure form of nickel from these laterite ores in a very economical way. So there is no shortage of the ores. It's just the will to actually invest the billions of dollars to do that. And I should mention, in the United States, of course, Mr. Biden wants to have these critical materials that are needed for the low carbon economy done, but there's a lot of reluctance to do mining in the U.S. because it upsets the environment somewhat, just like when you build a house on land, you're changing everything too. So there has been a lot of reluctance or difficulty to get mines approved, especially in the United States.
Well, you talk about mines and accessibility. What about then on the recycling side? Some metals are more recyclable than others. How recyclable is nickel as a metal?
It is extremely recyclable, and we'll say 100%. And so, for example, if you have stainless steel that has nickel in it, the value of the scrap that a scrap dealer will pay you is based virtually strictly on the value of the nickel in there. So if the more nickel in there, the more valuable it is. So almost all stainless steel that contains nickel gets recycled, and there is a high demand for it. One of the reasons is that the stainless steel market is growing at a rate of like 7 to 8% every year, and there isn't enough scrap around to fulfill the world's need for it. In North America and Europe, most of the stainless steel producers use 100% scrap or want to use 100% scrap, and sometimes they have to use carbon steel scrap and add a little bit of nickel and chromium and molybdenum to it to make the alloy that they want. But scrap is an important part. And as the market, I think, for stainless steel will drop a little bit, other countries will have that same, well, they have the demand for it already, but they don't have the supply of nickel containing scrap. So, for example, China is an example where, they're using a lot more stainless. I mean, the growth there might be 20% per year. They cannot beat it by scrap, but it is an important part. And because the value of nickel, it does get recycled. One of the most important parts with batteries is that everybody wants the battery to be recycled too, and there's all sorts of technologies being developed for that, and that will not be a problem either. And again, there's value in it, so it will be done.
Well, you mentioned the magic word as it comes to investing, which is supply and demand, and we're seeing this in so many elements and metals right now, that the supply out there, although it is available, the demand continues to grow. And starting this podcast today, I really didn't even think much about stainless steel, but you're saying that's growing both here and abroad, and that's got to be competing for inventory for batteries, which, as you mentioned, I think they were 3 to 4% of nickel use not that long ago. Today, I think you said it was over 17. Mm-hmm. Do you see that continuing to grow as well? And you see these two demands competing for one another in this space? And what will that mean for nickel longer term?
That's a good question. And there is a lot of, shall we say, uncertainties, radical technologies that can come along. And so everybody is trying to develop a battery that will give that long range, that will give the high energy density for it, but is less expensive than the traditional nickel-containing one. So, I mean, it is possible that something could come along in the next 5-10 years that will actually reduce the demand for nickel-containing batteries. Stainless steel, on the other hand, we see just a continued growth with it because as we think of sustainability, we want things to last longer. And I'll just take an example of our highways where today most Department of Transports will use carbon steel rebar, coat it with epoxy. I know in Toronto area here, it lasts about 15 years, and then you have to shut down the road, dig up the concrete, replace the rebar. Well, if you use stainless steel, it will last over 100 years. And so that's one of the more interesting markets. But it illustrates what can be done in the long term if you want components to last a long time. And of course, we often think of, okay, well, the stainless steel is more expensive than carbon steel. Oh, it might be 4 or 5 times the cost of carbon steel. But when you take into account, for example, on the rebar example, the cost of disruption of traffic, the costs of repairing, all these costs add up, and it's a clear case for stainless steel rebar in many applications. And things like the Champlain Bridge in Montreal, a critical bridge across the St. Lawrence River, they put in stainless steel rebar, demanded that it have a 100-year life, which was easy to meet. And so it was one of those examples where that market for nickel and the stainless steel is increasing.
You bring up a lot of really great points that there's so much diversity in the need and use of nickel that's actually growing, not just in the battery technology, but just in the infrastructure kind of globally in our economy. I'd imagine both here and abroad, those examples you gave about the highways and rebars, that's probably true everywhere, not just in North America. But are there any other topics that I've failed to mention or points you'd like to highlight as it relates to nickel overall?
Well, one of the demands that we see, we all talk about the low carbon future. We want the nickel to be used in the energy transition, and that is happening. We need it. So things like geothermal energy down in the Salton Sea in California, it's a very saline liquid that they get the heat from and then can generate electricity, but it needs high nickel alloys for that. In solar energy, there's a concentrating solar power where you have a mirror that concentrates the energy of the sun. And again, it needs nickel alloys for that. In the wind energy, all these wind towers that are going up, there's a huge demand for them, and people want to build bigger ones that have larger turbines on it, and you need a bigger tower. And we have a project going on now where by adding perhaps 0.5 or 1% nickel to the steel, you make it stronger, you make it more fatigue resistant, you give a lot of properties to it that are beneficial, and you reduce the thickness of the towers. The steel in them is maybe 50, 60 millimeter thick or even more, and they want to build bigger ones which will require thicker steel. And again, hydrogen, carbon capture and sequestration, those technologies will use nickel. And nuclear, which is getting a revival now because it is a low carbon technology, it does use a lot of nickel already and will use even more in the future as we want the reactors to last more than 25, 30 years, which was the original design life of them.
Well, it seems like nickel's everywhere. So you can't do anything without it, it sounds like, after this podcast. I encourage any of our listeners who want to learn more about Gary and the overall work that the Nickel Institute is conducting in their education series and so forth. I encourage you to go visit nickelinstitute.org and learn more about this fascinating, or as we like to say now, hidden metal. Gary, I really appreciate you making the time today to join us on Sprott Radio. So thank you for your time today.
It's my pleasure. Thank you, Ed.
And once again, my name is Ed Coyne, and thank you for listening to Sprott Radio.
This podcast is provided for information purposes only from sources believed to be reliable. However, Sprott does not warrant its completeness or accuracy. Any opinions and estimates constitute our judgment as of the date of this material and are subject to change without notice. Past performance is not indicative of future results. This communication is not intended as an offer or solicitation for the purchase or sale of any financial instrument. Any opinions and recommendations herein do not take into account individual client circumstances, objectives, or needs, and are not intended as recommendations of particular securities, financial instruments, or strategies. You must make your own independent decisions regarding any securities, financial instruments, or strategies mentioned or related to the information herein. This communication may not be redistributed or retransmitted in whole or in part, or in any form or manner without the express written consent of Sprott. Any unauthorized use or disclosure is prohibited. Receipt and review of this information constitutes your agreement not to redistribute or retransmit the contents and information contained in this communication without first obtaining express permission from an authorized officer of Sprott.